the joy of today is, this is going to be a short video. It's section 2.1 day 3, something called the sandwich theorem. Now, we are not talking about sonic. We're talking about a theorem that might also be called the pinch theorem or the squeeze theorem. And that's in other places. And if your teacher remembers, we always have some kind of sandwich today when we talk about the sandwich theorem. So let's take a look at what the sandwich theorem is. This is on page 65 in your book. Basically, if you say that a function, and we're looking for the limit of this, that's what we're looking for. The limit as x goes to some value of the f of x, we're looking for that. And so what we do is take the limit of two equations we do know, two functions we do know, we sandwich that f function in between them, and if these two limits are equal, actually we find two functions whose limits are equal, and then we can sandwich this f function in between them, and if these two are equal, well, that must be equal to the same thing, and that's what the sandwich theorem says. So take a look and read it that, and here are some examples. Okay, so what we do is we start out with a small, whatever we know. Okay, so I'll tell you what we know. We know, and this is always good to do in life, if you see something you really don't get, start with what you know. We know about a sine function. We know that a sine function goes between -1 and +1. It doesn't matter what it says, 1 over x, 2x, 10x, it doesn't matter what it says inside this angle argument. We know that this is between, that's a less than sign, -1 less than. Okay, we know that this function lies between 1 and -1. So I want to make inside here look like this. So the next thing I'm going to do is multiply this entire inequality by x squared. All right, that's legal to do. I would never do anything illegal because then I would be in math jail, and that would be a bad thing. You wouldn't have a teacher for a day. And plus I don't like handcuffs. So, not that I've ever had them on, but anyway, multiply everything by x squared, that's legal, okay? And then what we're going to do is take the limit, we want to know the limit as x go to 0, so that's another thing we can do. This is also legal. Take the limit as x goes to 0 of the entire equation. Or it's actually not an equation, it's an inequality. Take the limit as x goes to 0. Take the limit as x goes to 0 of the middle part. And then take the limit of the other side as x goes to 0. All right, so if I put a 0 in for -x squared, I get a 0. A -0, but it's really a 0. This one is a 0. So what must my limit be in the middle? It must equal 0. All right, and that's how the sandwich theorem works. Let's try one more example, just for fun. And we're going to start out the exact same way. We know sine is between -1 and 1, right? So how about if we just copy this, because why should I recopy the wheel? Someone's already made it. All right, so we know that sine of 1 of x is between there and there. Now remember, this can work for any sine function. If you have a sine, that will work, that it goes between -1 and 1, as long as it doesn't have another amplitude out here. Okay, so now we're going to multiply everything by x, because this equation has an x. And remember, we want we want the middle here to turn into the limit statement that's above. So -x. This is done exactly like the last one. Then we're going to take the limit. Oh, wait, no, I think we should add 5 to everything, don't you? Because that equation has a 5 added to everything. So we're going to go through and add 5 plus 5 to every single term. Minus x plus 5. 5 plus x sine of 1 over x. And 5 plus x. Maybe I want to write this one the other way just so we're consistent with how we're writing it. We're adding 5 to everything. Okay? 5, 5, 5. We added 5 to every part. Now we're going to take the limit as x goes to 0 of every single part. Limit 5 minus x. I'm going to take the limit as x goes to 0 of 5 plus x sine 1 over x. Now I have the exact, this is exactly like what our problem was. Okay, and now we have the limit as x goes to 0 of 5 plus x. All right, if I plug in a 0 here, I got the limit, 5 minus 0, that's equal to 5. If I plug in a 0 here, I get the limit of 5 plus 0. That's equal to 5. Guess what the limit is of this? It equals 5. All right, and that's how your sandwich theorem works. A 6-minute video, well, 6.3 quarters. All right, so happy sandwiching.